I have a brief presentation that John asked me to do. He said, Dad, I'm going to finish a little bit early. Would you mind talking a little bit about artificial intelligence? So what I can say is it's not brain surgery. It's not rocket science. It's maybe something that might be of interest. So I'm just going to spend the next 5 or 6 minutes. I recently took a class, a 12-week course in artificial intelligence, machine learning, and deep learning from MIT. And I wanted to talk just a little bit about some of the things I learned and the application of machine learning in medicine. And then we've got, after my brief presentation, several wonderful MedTalks that we'll bring up, and I will continue the conversation for today. I really appreciated listening, John, and yesterday to Gary and Todd, and I am excited to hear from Brian here in just a few minutes. I'm a technologist. That's where my career was spent. The last 40 years I started programming in 1976, 77, and I went through my computer science degree in the 80s, and then my JD MBA and my master's in computer science in the 90s. That was kind of the fun 90 time. And then I just felt like a continuous learning pattern is what I wanted my life to be about. And so when this opportunity came up to do a 12-week course in machine learning, of course I took it. Now I have to say that artificial intelligence, when I went through our computer science program, was like this futuristic thing that was super abstract. Nobody understood what it was. And there was all these predictions about what it would become. And most of us just ignored it and went and took an operating system course or did the network course because the internet and network computing seemed so much more relevant at the time. But I did start collecting what people said about the future. And I love this one of my favorite quotes from the mayor of Chicago on the invention of the telephone. He predicted that the day would come when every city would have one. So just a visionary, just could really see the future. I love this one on the television from Mr. Zanuck. He, on the invention of the television, said that we would get tired of staring at a plywood box every night. So have we become tired? I think we still do it a lot. I'm not sure how visionary this individual was either. I called on Ken Olsen, who was the CEO, president of Digital Equipment Corporation. And as I was flying home on the plane, I captured this thought. Ken, of course, DEC, everybody who knew DEC at the time, I was a salesman for them. I sold BYU their first 2 or 3 VAX 11 750s. And so it was that was the mini as a downsizing from the mainframe. But I was flying home on a plane and I saw this quote: "There is no need for any individual to have a computer in their home." And then I called on Mark quite a bit when he was at AOL. And so I was super interested in 2020 when he was speaking about machine learning, said, artificial intelligence, deep learning, machine learning, whatever you're doing, if you don't understand it, learn it, because otherwise you're going to be a dinosaur within 3 years. So it's 2023, that's 3 years. I don't see any dinosaurs in front of me. So I'm assuming you all became experts at it. One of my very favorite quotes, though, about technology comes from Arthur Clarke, 2001 Space Odyssey, and other science fictions. Any sufficiently advanced technology is indistinguishable from magic. When I saw some of these surgical presentations, by the way, I think they're almost indistinguishable from magic. What they're able to do just truly astounds me. I'm excited about it. So what is artificial intelligence? Well, we might call it something that says any techniques that enables computers to mimic human behavior. But anytime we do that, one of the things we're cautious about is that people say, wait a minute, they're not going to mimic the human. Computers have no body, no childhood, no cultural practice. They cannot acquire intelligence at all, let alone artificial intelligence. So you have to be kind of careful with the metaphors used to explain it. But machine learning is a subset of that body of work of artificial intelligence. And machine learning, I would say, is the ability to learn without explicitly programming. So when we went to school, we would create a program, write code to do a specific thing. Open that graphic. One of the very first things I did was to do an interrupt 21 handler to be able to handle information coming in. And it was very specific and targeted. With machine learning, what we're doing is we're creating an environment, an artificial environment where we can learn and where the math, the linear math, the statistics, the probability, the calculus, all of that can mimic processes of thinking and learning in ways that humans do, but it's not human. And then, of course, deep learning is an advancement of that, a subset of machine learning. In a deep learning, we learn to extract patterns from data. So we would take in our course an image of an MRI. We would have maybe 1,000 of them. And then we would go and take 700 of them, and we would train them that this little edge ridge here is a tumor, or this little thing here is a blood clot, or et cetera. And then we'd take 300 of them, run through and see how good the computer was at learning to find those very same kinds of structures in the new things that were done. It was fascinating to try it. And then you tweak and you tune and you learn from it. So it's taken off in a way that hadn't before. Why? What's happened? Because these algorithms, the linear math, has been around for quite a while. I studied it when I went to school in the late 70s and early 80s. So it's been around there for a while. We went through a couple of what I would call winters of AI in the 80s and the 90s, where money spent in the industry contracted. People weren't really sure where it was going. But in about 2013, 2014, there was this resurgence in growth in AR, AI, and why? Well, first of all, data. Finally, we had enough data to teach the computer to do something. It has a voracious appetite to read, to learn, to observe. And so we got more data and big data that could be stored in ways that were accessible. We got compute power. We finally reached a place where there was enough compute power to do the kinds of things we wanted to do. And we now have software, algorithms that have become open. I did not have to learn one thing. I did, but I didn't have to learn linear math in order to write the program that analyzed the data, because there were these libraries available to me. I could write Python code that go grab the libraries and say, set me up a neural network, take these images, scan them in, and let's begin working together. And I didn't have to learn the math. The math was there. And so that's opened up this whole resurgence of being able to use this based upon the people who have done that. If you look at this one ImageNet graphic, so ImageNet took over 1 billion images and scanned them in and used the largest applications of Amazon's Mechanical Turk to take workers from 147 countries around the world that would look at that and say, that's a dog, that's a cat, that's this, that's that, and learn to label the data. That's called supervised learning, where you take it, you train the computer to see things, and then you run your testing data through it to see how observant it has become. But when you try to take 5 or 6 minutes to explain machine learning, it's a tough task. So I was thinking about, how can I explain what I have learned and what the machines learn through this experience? And I thought about, one way to think about it is to step back and ask, how does a child learn? We have children. I've had 5 of them, wonderful people. And I've watched them learn over time. Well, they learn by experience. They learn to go on and finally say mama or dada or whatever they say. They learn by observation, repetitively looking at things, by practice. They have caregivers, a mom who sits and reads with them. This is my daughter, Rebecca, with little Brigham, and she's pointing out things in a book and teaching him with care. I noticed it's interesting that Ty, her second son, is right behind her on a computer doing whatever he's doing. So we give them these tools, we give them these environments, and they begin to learn. Well, computers aren't that much different if you think about it. First of all, if I see Brandy there, I can say I see Brandy and I don't have to describe to you what the eyes are doing or how the brain is functioning or what I'm doing in the pathology of me in order to recognize. I see Brandy and I can recognize her and I can label her with a name. Well, computers learn in similar way. They don't have experiences, but they ingest data, massive amounts of data. So I'm going to show ChatGPT in just a moment. It has read every medical textbook on the planet. It's looked at every article on politics, on sports. It's ingested every image it can think about. It's gone through this massive learning process of ingesting information, categorizing it. It doesn't have observations, but it has math. And it can take an input and through linear math and other forms of math and a loss function and an alias or bias function, it can come back and predict how efficient is this? What is the error rate that I'm going through? How do I experientially teach the computer, no, that's not a dog, that's a cat? And it does it through both supervised, which means there are people looking at what it's doing and correcting it, but also unsupervised, which means it's purely looking for patterns in the graphic. So for example, if it's looking at these pictures, we took one project where we took 1 million photographs and pictures, and we would get it first to look at the lines and the structures. Where did the light change? We took MRIs, actually, and did this, and we picked up pituitary tumors with it by just looking at the contrasting and the elements that were composed in the graphic. And then we would take that, it would learn to see lines and breaks. It would learn to see eyes and nose and ears and teeth, and pretty soon it could start putting together faces. And then we could say, well, that face is me, that face is John, that face is... So if you've ever used a tagged Instagram environment and you've seen yourself tagged, it's because we've got these back-end processes who are doing that for us. If we've ever used, say, Siri or Alexa, you've got machine learning going on and doing that kind of work, and it's all happening because of these wonderful technologies. How many of you use ChatGPT? A good part of the audience, so you know what I'm talking about. What is it? Well, first of all, I might just say that ChatGPT got its first 100 million users within 60 days. Now, that's the fastest growing consumer application in the history of the world. So if you think about it for a moment, YouTube took about 5 years to get there. Instagram took about 2.5 years. What else do we use? TikTok took 9 months. So many of these applications took a while, but to get to 100 million worldwide users in under 60 days is just truly amazing. What is it? What do you mean ChatGPT? Well, first of all, there's a chat component. I'm going to carry on and show just a couple of videos of chatting with the computer. It's a to and fro kind of experience. It remembers roles and contexts. It knows who I am. I fed it. I'm a new student of machine learning, and I have these kinds of properties. I love BYU sports. I love to read. I love to cycle. I'm interested in religious texts. It knows that about me. So you'll see in some of the answers that it contextually applies what it knows to me as the person asking the questions. But it's a chat. It's a conversation. The G in GPT stands for generative. So it's taking a question, and there's not a direct mapping from that question to the answer. What it's doing is decomposing that question using what predictive math it has to say, I think that's what they're talking about. These are the subjects and the words I'm used to seeing when I see a topic like that. I'm going to generate a new answer. So I asked the computer in just a moment to give me a limerick. And you'll see it generate a limerick targeted at me. But the funniest one is coming up for Gary. I asked, why did the orthopedic surgeon cross the road? And you'll have to wait for that answer. P in ChatGPT is pre-trained. So we feed it all this information. We train it to understand what it is. And then we use these things called transformers or perceptrons or whatever name we're using, neurons, to take that information and begin building patterns and relationships between it. I took a database of 1 million songs and the viewing behavior of people who listen to those songs on Spotify. And it had 1 million rows of data, had 784 features or attributes. So it's a big matrix. Now, you and I can see in 1 dimension. We can kind of put things on a scale in 2 dimensions. We could have a 3-dimensional object and see a dot in space. But when you get to 784 dimension, we don't think that way. But a computer does. A computer could go through and say, I recognize this individual as being very similar to these other clusters of individuals who love this song. So I'm going to recommend it to you. And it'll do that very thing. So I went to ChatGPT, and the first thing I said was, well, give me a limerick. And that's all I said, give me a limerick. This is what it came back with. In Lehigh, where mountains stand tall, I cycle and play sports with a ball. In my surgical quest, I work hard and invest while reading religious texts in the hall. So I thought that was kind of fun. And why did it put Lehigh in there? Well, that's where I live. Why did it talk about cycling? Well, I love cycling. People who know me know that. In fact, when we moved to the new home, the biggest issue for me is where is the cycling path? How close it is? Because that previous home, it was right next to my front door almost. It knew I liked BYU sports, so it could give me that. So then I said, okay, let's have some fun with this. What if I do ask, why did the orthopedic surgeon cross the road? I realize we're not speeding this up or doing anything. This is the time in which it responds. Well, of course, we all know that the orthopedic surgeon crossed the road to fix the chicken's broken leg. That was great. It came up with that on its own. It knew what I was talking about. It understood the context. It understood what an orthopedic surgeon was. It knew what it did. Is that human? No. But is the math pretty astounding and indistinguishable from magic? I think so. I then said, okay, well, I have to give a presentation today. I need about a 30-second summary for medical providers on what is machine learning. If I'm going to give a presentation like that, what would you say? This is what it told me. Okay, we'll give them this. Machine learning is a powerful tool in healthcare. It uses computer algorithms to analyze large amounts of patient data and identify patterns that can aid in diagnosis, treatments, planning, and predicting health outcomes. By harnessing machine learning, medical providers can make more accurate decisions, personalized treatment, we heard about precision medicine a little bit yesterday, and improve patient care. It's a game changer in healthcare, offering the potential for that. So I didn't coach it in the answer, but I was aware of what my context was and who I was, and so it offered the answer. I said, can you give me a concise list on the number of areas? Now, what's interesting about this list is when we went through our course, we went through and we did mimic play projects. I would call them toy projects associated with each of these areas. We took disease, that pituitary tumor experience, and I could identify about 72% of the time, which is not as great as Dr. Anderson's coming up, but the system could just identify that is a tumor right there, or at least it's a good candidate, so it's pretty good. We could personalize treatment. Now, we're doing an app, as you know. Just a brief update on the app. We're now using the app with about 50 patients inside of our practice. We're still very early stages, but I have started collecting data. Not data that's specific to an individual, but what types of surgeries we're doing, what types of notes is it doing, how can I use that to improve our processes. It's just early stages, but it's been kind of fun. So these are some of the areas that are important about that. Lastly, I asked it, can you show me some companies that are dealing? Now, I realized that this data was ingested in 2017, 18, 19, and 20 in this version of ChatGPT. So it'll have company names here, has Medtronic on here, which is one of our sponsors. It would be early days, though, to have everybody who's participating in machine learning be there. But it is a pretty interesting and good list. So here you go. Of course, it takes IBM Watson Healthcare, Google Health, Siemens Health, Philips, Zebra, Path AI, which is a wonderful project, Medtronic, et cetera. So ChatGPT is just one example of how machine learning is being used. And you probably aren't aware of it, but you've been using it all along. If you've taken your phone to do a speech to text, or to use it to create a message to send to somebody, you've used it. If you've gone there and seen yourself tagged on Instagram, you've used it. There's so many different places where it's being used, it's kind of fun. It has a lot of applications to medicine, translations to different languages, ability to target patient care, sentiment analysis. If I get feedback from a patient, is it positive or is it negative? You're able to go through and it can identify when it's positive, negative, based upon the words that are used and the tone in which those words are used. And it's had billions of opportunities. If you look at ChatGPT, it has 178 billion adjustable knobs, if you can think of it that way. So imagine just tuning those, and the math is constantly turning it to improve the way it works. Well, is machine learning indistinguishable from magic? Is it reliable? Is it ethical? Is it scary? I think there's lots of questions about machine learning that we need to get to, but it was fun, and it was a pleasure to speak to you just a little bit about it today.